What you see here is actually a cross-section of a room. And here is an inflow like you have everywhere in the room that brings air in through the air conditioning system, and an outflow that takes the air out to condition it and recycle it. And here, for example, there's a window that might be open or closed. And what you see here is the circulation of the air in the room under different conditions. For example, open window or closed window, or maybe if the inflow is fast or slow, depending on how fast the vent is running. And you see that there are several different circulation patterns. So what our technology is trying to do is try to position sensors on the wall, these are examples of sensors, to sense at the wall the airflow and try to understand what is the airflow in the whole room. And what you see here is that our system is able to understand which of the 4 types of patterns it observes just by looking at that sensor data for very few sensors. And what you see is that you have several different patterns depending on whether the window is open or closed and whether the flow is fast flow or slow flow. The eddies appear in different places. So for example, you might have an eddy here and an eddy here, or you might have just one big current or just small here and another one forming here. The sensors cannot see that. The sensors can only see what's happening right next to them. And what we're trying to do is we're trying to understand, given the models of the room and models that we have developed offline and run and simulated, how from the data, the sensors, we can understand what's happening in the whole room. What we're trying to do is understand the flow pattern so that we know how the flow pattern affects the temperature and the comfort of the users in the room. Once the system knows the flow pattern that exists, it can then make modifications to either improve it, to improve the comfort, or improve the temperature distribution, or change its operation to make the same flow pattern more efficiently. What has happened recently in the area of sensing is there's a revolution in terms of how we understand systems. And what we have here at Merle is a very good combination of experts that are experts in fluid dynamics, in control, and in sensing. And what we're able to do is combine these fields and understand the system in a much more holistic way and get these patterns. The future of HVAC is a very subtle motion of air through the room. So conventional HVAC systems actually force a lot of air, and that's how you get cold or hot or whatever temperature preference you are. The new wave of HVAC systems will actually rely on very subtle airflows. So you'll have a chilled ceiling, maybe a heated floor, a few vents, and very small circulation of air. And using this technology, you can make those systems to be much more efficient and much more comfortable to the user. Sensing the flow is actually not very easy, and we're developing hardware to actually sense the flow and understand the flow better. This is a very interesting technology that can be very disruptive long-term in the industry. It's still nascent in its development, but we have very high hopes about its potential.